so it's time to check for a win. So a couple different options here. So the main thing is checking for a win. We need to check essentially 3 different cases, right? So we want to see if we have 3 marks in a row going in one of the rows. We have to check the columns, right, for 3 in a row, and then we have to check each of the diagonals, all right? Now this is basic logic. So, I'd encourage you, if you want some practice with Kotlin and practice with writing game logic, go for it, all right? I'm going to take a little bit different approach, and that's I've done this for us offline, and I have them stored. So if you're taking this class for credit, you'll actually see in the slides for the class that in the notes here that there are all the functions that we need. So I'm going to paste these in. If you're following along just with the videos and not for class, I'll go ahead and show you what we have, and we can kind of see what you got, and I'll put it up on the screen so you can pause the video and use it to check your work, or just type along what we have. All right, so let's talk through what we have. So check for win. The first thing is that if we've already have a win, right? So in other words, if it's not X's or O's turn, remember our other game states are either X wins, O wins, or it's a tie, then we just return. There's nothing else to do. All right, the next part is I'm checking X's and O's separately. So I have to check here if X won, right? And we're going to write a little separate function for that. Then we'll do that. Then we'll set it to X wins. If O won, so if mark.markO won, then O wins. Otherwise, we're going to check to see if the board is full. All right, and if that's the case, then we're going to update it here. Cat is just a fancy name for a tie game, so I've used that in the past. All right, good. So I'm passing in marks. Remember, we said that marks are actually their own enumeration. They're not a type. So I'm going to update this type here for did piece win, and we're going to say that it is of type mark. All right, and that's probably going to change some other logic, but let's see what we got here. All right, so first thing we're going to do is check wins going across, right? So we're looping over our three rows. For each row, we assume that they're going to win there, and then we just keep chugging along from column to column, place to place. And if we encounter anything that isn't the one that I'm checking for, like the first time I call it, it's going to be X. So if I find something that's not X, then I just set it equal to false, right? So there's only 3. So very good. So it's just set equal to false if I find anything. Now if I survived that whole for loop, right? So it started off as true, and if it's never gets set to false, that must have been because they really were all the same and the one that I was looking for. And if that's the case, then I'm just going to return. I found a row in one of those, or I found a win in one of those rows. The next logic is very similar, only let's look at the code here. You're going to see one very small change. See it? Yeah, so to check wins in columns, I'm just switching my loops. So I start off with a column as the outer loop and rows are in the inner loop, but the logic otherwise is identical, right? To check for wins in columns, right? So no new ideas there. Then I'm going to check my diagonal separately, right? So again, I have my win here, and I'm reinitializing it since this one right here was just local to this for loop. I could have initialized it outside. A little bit different pattern. And I loop over. Now, if it's the main diagonal, then I'm looking for things like 0, 0, 1, 1, 2, 2. In other words, I just need one index because row and column are going to be the same. All right. And same logic. If I ever find something that doesn't match the mark that I'm looking for, I set it to false. But hey, if it survived, I found a win, right? And then I'm going to have the same thing in the off diagonal. Again, I only need one variable, but then columns as a function of rows, right? So I'm going to want things like 0, 2, 1, 1, and 2, 0, right? 0, 2, 1, 1, yeah. So I guess going that way. And so I can write that as a function here by just saying it's really the number rows minus 1 and then minus the current row. And you can verify that, kind of walk through that and see that that's indeed the case. All right, same logic otherwise. All right, so that's all of my did piece win. All right, just saved myself some typing here to just explain it instead. The next method is board full. So is board full should be pretty straightforward. So so nested loop here. So I'm looping over all the rows and columns, and if anything is none, right, then I just bail immediately, right? So hey, you found something that's actually there, or a place that's actually empty, then the board is not full. Okay, so there we go. That's that. All right, so let's write some unit tests for this, or rather copy some unit tests for this. So I'm going to go back here to my slides, go ahead and grab those unit tests, and we'll dump them back down. And okay, like so. And it looks like I just updated here. So instead of saying X win, I was doing X wins. So I'm going to change a couple of these real quick. Tie game and X wins. All right. And the tests themselves that are here, all right, so I'm just basically clicking through the game, right, and coming up with different wins. So I'm testing whose turn it is, and eventually X is going to win on this one. This right here is a force win, so where X sort of forks O. X chooses the center, O goes to the side, X chooses a diagonal, and thereby is going to force a win. I can detect a tie in here all the way through to the end where they go to the end and then they tie, and this is one more test for the diagonal, right? So a smattering of different tests here. So let's see how we did with these tests, and we passed the test, right? So we have good logic as far as we know according to these tests. All right, so a couple more things that I'm going to need. We really are almost done, but we're going to need to get the game state in a public way, which will be handy for us from when we go to do our controller. So I'm going to want a function here called string for game state. So far, when I've been testing, I've been using the making my game state non-private, right? So I can access it from outside. But here I might want a string, and this string will be handy whenever we want to display things on the board, right? So if we're in the state of X's turn, it should say it is X's turn. Or if O wins, it should say, hey, O wins the game, something like that. So we want some strings here. So this is going to be a couple things. So this guy is going to return a string like so. And we're going to need some actual strings to use. So this is text that's going to appear, so substantial text beyond just X's and O's that are going to appear on our screen. So we should go ahead and take a look and create some strings in strings.xml. All right, so in strings.xml, my only string so far is just TicTacToe. So I'm going to go ahead and put another few in here. All right, so you remember we need to give them some sort of an ID and then the actual value. So the ID is going to go right here. So we'll do one for X's turn. All right, so simply so a string called X turn, and that's just going to say X's turn. All right, like so. Let's try just X turn. All right, they didn't like the apostrophe without me doing some extra stuff here. So let's see. So we're going to have a string for O's turn. All right, and then let's see. So our other game states that we're going to need are going to be, so we'll say X wins. X wins, like so. And then O wins. And then we'll need one more for tie game. Tie game, like so. And maybe actually we want to, do we want to capitalize these guys? Sure, we'll go for it here. This is going to show up on my screen, so I could do it like that. Let's see, while I'm here, I might as well do some other things. So I'm going to have a button for doing a new game. All right, so I'm going to have a string here for new game. We'll use this when we do the controller. And let's see, I think I actually want to do one more thing. We might not appreciate why yet, but I want an actual one with a space in it. so that I can space out my buttons. Just putting a space in here isn't enough. You actually have to put it in quotes, so it actually puts it there. Actually don't need it quite yet for the test I'm going to write, but these last two things we'll use a bit later. All right, so going back to our game, so we want to return a string for the game state. So we want to say, depending on our state, return one of these different strings. So we can do this with what's called a when statement in Kotlin. So when is kind of like a switch. Depending on different values, like for instance of an enumeration, you can return different things here. So game state is what we're going to be switching off of. And depending on what the game state is, we're going to do different things. So if the game state is X's turn, all right, we want to, right? So we're going to use the arrow operator here. We want to return that string for X wins. Now, if I start to type in r.string .x wins, that is actually going to return me an integer. This is just a resource ID. It's not the string itself that we defined here. Remember, we need to call getString on this, and you remember this from when we did it in Hello Button. The only problem is the getString is not a part of TicTacToe game. Remember, we use getString from an activity. We don't have an activity here. Well, actually, it was from the context from the activity, but we don't have to worry about that. Other than we need a context. So this is a good opportunity for us to build in another constructor. So I'm going to scroll all the way back up to the top here, and we're going to make what we call a secondary constructor, okay, that takes a context. Okay, so a context of type context right here. And we're going to save it off in a field. So my third parameter up here is going to be private context. So we'll make it a val context of type context. And it doesn't like that. So if you do a val, then it's saying right here that you have to initialize it or make it abstract or do something which is not what we're doing here. So there's another option. I know that if I call this constructor that it's actually going to get initialized. So I could tell Kotlin, I could give it a promise to initialize it, and that's what's called a late init var. So in other words, I'm not going to initialize it right now, promising to do it later, and this is how I specify it, right? So it's going to get initialized in my constructor, all right? So very good, and I don't want that as a primary constructor because I want to be able to construct things with or without a context, depending on what I'm doing. So this context here, we're just going to go ahead and store. So this .context gets the context that I pass in. All right. So now I actually have a context available, right? So assuming that I actually construct one with a context, and now I can call context.getString. All right, like so. All right. So that's good. And really, what I want to do is I want to return. I want to return this guy. That's the logic that should occur when I do that. Now, all of my different cases here. So I'm going to have, like 5 different ones, right? 5 different game states, and they're each going to return a different string. Let's see. So they're each going to return. So I can actually, Kotlin lets me factor things out here because an expression like a when or an if is an expression. It has a value, and it has a value depending on what the condition is. So the value of the when is going to be whichever on the right-hand side evaluates to a true statement, okay? So depending on what the game state is. So I said X's turn, then the value that's going to get returned is this string here that I'm pulling from my string resource. This guy right here is going to be r.string dot, let's see, so this is O turn, and I just realized I screwed this up here, right? Unit test would have caught that, but let's try to get it right here. So X's turn, so let's return X's turn, and then a couple others. So if we look, it's complaining because it says that when you have when, you either need an else or you need to make it exhaustive, right? So I'm still working on making it exhaustive, right? I'm checking out all of my different ones here. So we'll just let the compiler chill for a couple of minutes here, and we'll ignore it. So this is X actually wins, so X wins. And then if O wins, contexts. Feel free to copy and paste if you like. They're all the same. So O wins. And you'll notice that as I start to type these in, the options here keep getting smaller every time. So I've already had the other 4, so it knows the only one left is tie game. All right, and as soon as I click in tie game, that error goes away because now I have hit all 5 things in the enumeration, which is why I use the enumeration, because it makes things like this really nice. So context get string, and this is r.string.tieGame. Okay. Again, you might wonder, why aren't we just using strings directly? Enumerations make our logic cleaner, make it independent of the actual string that we have. And why didn't we actually just hardcode our strings in here? And again, because significant screen text in Android should go into strings.xml. We'll see later that that's going to enable things like actually translating to other languages based on the location of the phone. It's going to make that really easy to do. So it's very good best practice, right? So now we have our string for our game state, and it returns it. All right, very good. So that's our model object. I think it's going to be complete for now. In our next video, we're going to go ahead and build up our view and then eventually our controller. And if we need to make any tweaks on this based on what our needs are there, we will. But I think this is a pretty good first pass. All right, see you next time.